Hi class, in this video here we want to talk about some trigonometric identities called sum and difference formulas. And what we're going to do is we're going to work through three objectives here. First, we're going to use the formula for the cosine of the difference of two angles, and that's just going to be to help us get used to the basic concept or the basic formula. And then what I'm going to introduce is the sum and difference formulas for sine and cosines. And then the last thing we'll do is we'll do a quick example at the end talking about how you use the sum and difference formulas for tangents. And this lecture here, what it's mostly going to be is I'm going to introduce the formulas to you, and then we're just going to work a ton of examples so you can see how this is used. All right, so let's start. So first off, the cosine of the difference of two angles is given by this formula. If you have cosine of alpha minus beta, okay, a little bit of a typo here. You can see that this is just going to be equal to, here's the typo, cosine of alpha times cosine of beta plus sine of alpha times sine of beta. Okay, and so the cosine of the difference of two angles equals the cosine of the first angle times the cosine of the second angle plus the sine of the first angle times the sine of the second angle. And what we'll do here is I will do some examples here, to show you that this actually works out. Okay. All right, so let's verify this just to show you that this works, okay? So we know that if you look at the unit circle here, we know that cosine of 30 degrees. So I have the unit circle here in 30 degrees. Okay, so here's 30 degrees down here. We know that right off the bat, we know that cosine of 30 degrees, just looking at the unit circle, is the square root of 3 over 2. Okay, so I want to show you using this formula right here, okay? Obtain this exact value using cosine of 30 is the same thing as cosine of 90 degrees minus 60 degrees, okay? And I'm going to do this using the difference formula. All right, so look, cosine of alpha minus beta. This is just from the previous slide here, just recopying the formula. This is cosine of alpha times cosine of beta plus sine of alpha times sine of beta. And so look here, I have cosine of 90 degrees minus 60 degrees. And look here, this is my alpha and this is my beta, just directly looking at it through the formula. All right, so my alpha is 90 degrees, my beta is 60 degrees. So this is cosine of 90 degrees times cosine of 60 degrees plus sine of 90 degrees times sine of 60 degrees. All right, now let's just look on our unit circle and show this. Okay, so what exactly is cosine of 90 degrees? Well, that's 0. Cosine of 60 degrees is 1/2. Plus sine of 90 degrees. Well, what is sine of 90 degrees? That's 1. And then what is sine of 60 degrees? Square root of 3 over 2. So look, 0 times 1/2 goes away. 1 times square root of 3 over 2. Yeah, look. Using this formula here, we got the same exact thing. So this formula absolutely works. Absolutely works. All right, let's try another example so you can see how this will be used. Okay. Find the exact value of cosine of 70 degrees times cosine of 40 degrees plus sine of 70 degrees times sine of 40 degrees. And look, if you look on the unit circle here, there's no cosine of 70, no cosine of 40. But look, this looks exactly like, look, cosine of alpha minus beta is equal to cosine of alpha times cosine of beta plus sine of alpha times sine of beta. Well, look what I have here. This is cosine of 70 degrees times cosine of 40 degrees plus sine of 70 degrees sine of 40 degrees. So look, I've got my alpha and beta, okay? So alpha is 70 degrees, beta is 40 degrees. So watch this. Well, look, cosine of alpha minus beta is now equal to cosine of 70 degrees minus 40 degrees. Yeah, I'm just going backwards in the formula. Now what is 70 degrees minus 40 degrees? That's 30 degrees. And this you can absolutely see on the unit circle here, okay? Square root of 3 over 2. So you get the, it's another way of showing the previous problem, but you get the idea here. All right. Now, so I said this is a trigonometric identity here, this formula here, okay? So let's use this now to talk about how you verify identities here, okay? So I want to verify this trig identity here, okay? That cosine of alpha minus beta divided by cosine of alpha times cosine of beta is the same exact thing as 1 plus tangent of alpha times tangent of beta. All right, so if you remember from our previous lecture, how did we verify this? So you got to pick one side of the equation to work with. So I'm going to pick this side right here. Okay, so I'm going to work with the left-hand side. And so what's going on here is I'm going to sub in the difference formula here, okay, for cosine of alpha minus beta, okay? So plug in the difference formula. Okay, so what do we know cosine of alpha minus beta is? Well, that's cosine of alpha times cosine of beta plus sine of alpha times sine of beta. And this is all divided by cosine of alpha times cosine of beta. And when I simplify this, it's going to be equal to 1 plus tangent of alpha tangent of beta. So here's what you're going to do. You're going to take this expression here on the left-hand side, and you're going to write it as two fractions. Okay, so it's cosine of alpha times cosine of beta all over cosine of alpha cosine of beta plus sine of alpha sine of beta divided by cosine of alpha cosine of beta. And I'm hoping that I can now simplify this to be 1 plus tangent of alpha times tangent of beta. Well, it does. Look at this. Cosine of alpha cosine of beta divided by cosine of alpha cosine of beta. That's obviously just 1. Plus, look, if I group just sine of alpha cosine of alpha, what is that? That's tangent of alpha. What is sine of beta? Cosine of beta. Boom, tangent of beta. So yeah, we proved it. So we got it. So you can use this whenever you have these problems now with verifying identities. You can use this formula to help you solve or verify these trigonometric identities. All right, so now we're ready to talk about the rest of them. Okay, so we've looked at here just the difference of the cosine of the difference of two angles. So now we can talk about formulas for the sum and difference for cosines and sines, and here they are. And so what you should do is as you're getting your notes together or having a note sheet of all these different trigonometric identities, you should slap these on there. So cosine of alpha plus beta is equal to cosine of alpha cosine of beta minus sine of alpha sine of beta. We just did cosine of alpha minus beta. Okay, that's cosine of alpha cosine of beta plus sine of alpha sine of beta. Sine's a little bit different. Okay, sine of alpha plus beta is going to be equal to sine of alpha cosine of beta plus cosine of alpha sine of beta. And then sine of alpha minus beta is going to be equal to sine of alpha cosine of beta minus cosine of alpha sine of beta. All right, let's use these here. All right. So let's find, and I've got the unit circle here for reference, find the exact values of the following here. Okay. So the first one is sine of 60 degrees minus 45 degrees. So this is, in this formula, this is my alpha, and this is my beta. Okay. So look, we're just going to use this formula here. It's sine of alpha times cosine of beta. So this is sine of 60 degrees cosine of beta. so cosine of 45 degrees, plus, going back, oops, sorry, minus, I'm sorry, it was a minus in there, cosine of alpha sine of beta. So minus cosine of 60 degrees sine of 45 degrees. Well, let's use our unit circle. All right, what is sine of 60 degrees? It's square root of 3 over 2. Okay, what is cosine of 45 degrees? Square root of 2 over 2. Minus cosine of 60 degrees, that's 1/2. And sine of 45 degrees is square root of 2 over 2. Well, look, square root of 3 times square root of 2 is a square root of 6 over 4. Minus this just becomes a square root of 2 over 4. So this just simplifies to the square root of 6 minus the square root of 2 over 4. And that is its exact value, okay? And like, let me show you that this is true. Like, let me load up the graphing calculator here and just show you that, yeah, this all works out, okay? So look, when you want it, if this is in degrees, just go to mode and make sure your calculator switch from radians to degrees, okay? So look, sine of 60 minus 45. What is that? 0 point whatever this is. Now let's see if this is what that is equal to. All right, so square root of 6 minus the square root of 2 divide by 4. Look, you get the same thing. So we found the exact value using this formula here. All right, let's take a look at this one. Notice that this is just saying sine of 105. So what you have to recognize is, well, wait a second. Is 105 degrees the same thing as 60 degrees plus 45 degrees? Yeah. And look, I have 60 degrees 45 on here. So I can just use this formula here. Sine of alpha plus beta is sine of alpha cosine of beta plus cosine of alpha sine of beta. So look, this is my alpha. This is my beta. Okay. So this is equal to sine of 60 degrees times cosine of 45 degrees. Okay. Plus cosine of 60 degrees sine of 45 degrees. And then here, you can just jump right to the unit circle. Okay. Sine of 60 degrees is the square root of 3 over 2. Cosine of 45 degrees is the square root of 2 over 2. Plus cosine of 60 degrees is 1/2. And sine of 45 degrees is the square root of 2 over 2. And so here you can see it's, the flip here, right? So this is the square root of 6 over 4 plus square root of 2 over 4. So this is just the square root of 6 plus the square root of 2 all over 4. And if you want, you can verify this in your calculator and you'll get the same exact thing. All right. Look, let's just do another one, just so you could, what I encourage you to do here now I've switched it to radians, okay? What I encourage you to do here is, just pause the video, right? And, make sure that you can, solve this and come back and then watch me do it. And then I'll show you, I'll wait 5 seconds and see if you come back and after you pause it, and I'll show you, what I get. All right. So I want to find the exact value of sine of 5 pi over 12 using the fact that 5 pi over 12 is the same thing as pi over 6 plus pi over 4. So this is sine of pi over 6 plus pi over 4. Well, look, here's pi over 6 and pi over 4. So look, just using our formula, what does this become? Okay. This is sine of pi over 6. This is my alpha. This is my beta. sine of pi over 6 times cosine of pi over 4 plus cosine of pi over 6 times sine of pi over 4. All right, well, what is sine of pi over 6? Well, just look at, look at the unit circle. Pi over 6, sine, 1/2. Cosine of pi over 4, square root of 2 over 2. Plus cosine of pi over 6, square root of 3 over 2. Sine of pi over 4, square root of 2 over 2. So look, this becomes square root of 2 over 4 plus the square root of 6 over 4, which is the square root of 2 plus the square root of 6, all over 4. So we got it. All right, so just a little bit of an interesting trick here. Let's now go back and let's verify some more trigonometric identities. We've been doing a lot of that, but we've got this new formula here. So let's talk about now how we can verify this. Cosine of alpha plus beta plus cosine of alpha minus beta. I'm going to claim that this is equal to 2 times cosine of alpha times cosine of beta. And so look, you're going to have to pick a side to work with. You're going to work with this one here. All right, obviously. So you're going to substitute in cosine of alpha plus beta using the sum formula, which is cosine of alpha, cosine of beta, minus sine of alpha, sine of beta. So I'll just write, we're going to start on left-hand side. And plug in the sum difference formulas. All right, so cosine of alpha plus beta becomes cosine of alpha times cosine of beta plus minus sine of alpha sine of beta plus, now substituting in for this is cosine of alpha cosine of beta plus sine of alpha sine of beta. And you're going to notice immediately that's going to just simplify to 2 cosine of alpha cosine of beta. Look what cancels. Sine of alpha, sine of beta, sine of alpha, sine of beta, minus, minus. So I have cosine of alpha, cosine of beta, plus cosine of alpha, cosine of beta. And absolutely, does that equal 2 cosine of alpha, cosine of beta? Because there's 2 of them. So again, this is just like the substituting or verifying trigonometric identities that we've done before. You just see we have a new formula to work with. All right, let's try this one. We'll do another one here. All right, so let's verify that sine of alpha minus beta divided by cosine alpha cosine beta is equal to tangent of alpha minus tangent of beta. All right, so right off the bat, you're going to work with the left-hand side, okay? You're going to substitute in the difference formula here. All right, so, if you need to, can always go back. Sine of alpha minus beta, what is that? Sine of alpha cosine of beta minus cosine of alpha sine of beta. All right, so substituting in first here in the numerator. This is sine of alpha cosine of beta minus cosine of alpha times sine of beta, all divided by cosine alpha cosine beta. And this is, we're going to see, is going to simplify to tangent of alpha minus tangent of beta. All right, so what should you do when you have something like this? Let's split it. Okay, so sine of alpha cosine of beta all over cosine of alpha, cosine of beta, minus cosine of alpha, sine of beta, divided by cosine alpha, cosine beta. Okay. Well, look, just like, check this out. Look what cancels here. Cosine beta, cosine alpha there. So look, what are you left with? Sine of alpha divided by cosine of alpha. What is that? That's tangent of alpha. Minus sine of beta divided by cosine of beta. That's tangent of beta. So we got it. All right. So now I want to switch gears and talk about some, go back and do some right triangle trig with this stuff. Got some fun problems here. Okay. All right. So suppose that you're given the following information. You're told that sine of alpha is equal to 4 divided by 5 for a quadrant 2 angle. And what you see here is I have a picture that describes it. Okay, so what you're going to do is alpha is this quadrant 2 angle, all right, and you're going to set up a triangle that describes it. Okay, well, you know, remember your SOHCAHTOA. Okay, sine is opposite over hypotenuse. Cosine, okay, is adjacent over hypotenuse. And tangent, okay, is opposite over adjacent. If you need to remember that. And look, I'm saying sine of whatever this is 4/5. Well, what is sine? Sine is the opposite side, and the 5 here, okay, is the hypotenuse of the right triangle here. Okay. So look, what we're gonna do here, all right, is I'm going to ask you to find some different values here. So what it might do helpful here is you're going to notice that, hey, I don't know what the adjacent side is here. But this has to be a 3, 4, 5 right triangle. But because it's quadrant 2, here, this is equal to -3 because it's in quadrant 2. All right, and then you're also told you have sine of beta is equal to 1/2, and this is for a quadrant 1 angle. Okay, so here's beta, and here's your right triangle. All right, well, you know, set up the triangle for this, all right? So sine is equal to opposite over hypotenuse. So that's 1 over 2, because that would be the hypotenuse. So then you just have to find, you know, x here, okay? And you can use the Pythagorean theorem. So I know a is 1, so this is 1 squared plus b squared is equal to 2 squared. Or b squared is equal to 3. And because it's a quadrant right angle, x here, this adjacent side, has to be a positive number. So it's just equal to the square root of 3. All right, so I'm going to ask you to find all these things here. Okay, find cosine of alpha, cosine of beta. All right, cosine of alpha plus beta, sine of alpha plus beta. All right. I'm also going to find sine of alpha, which I have, and just write sine of beta too. All right, so cosine of alpha. Here's alpha. Cosine is adjacent over hypotenuse, so that the adjacent side here is -3, 5. All right, -3 over the hypotenuse is 5. I've got sine of alpha. That's 4/5. So let's find cosine of beta. All right. Cosine of beta here, all right, well, cosine is adjacent over hypotenuse, so what is it here? It would be the square root of 3 over 2, and then I also have what sine of beta is here. Okay, they gave us that. All right, so now we're going to use this, all right, to help us find the following. All right, so we've got to find now cosine of alpha plus beta. All right, well, just what is the formula for this? This is cosine of alpha times cosine of beta minus sine of alpha, sine of beta. Well, look, go back. Cosine alpha is -3/5. Cosine beta is the square root of 3 over 2. Minus, okay, sine alpha sine beta. Well, sine alpha is 4/5, sine beta is 1/2. So look, what is this? This is minus 3 square roots of 3 over 10 minus 4 over 10. So we can just write this as minus 3 square roots of 3 minus 4 over 10. And we've got it. Boom. Sine of alpha plus beta. Well, what is that formula, right? That's sine of alpha times cosine of beta plus cosine of alpha sine of beta. All right, sine of alpha, 4/5. Cosine of beta, a square root of 3 over 2. Plus cosine of alpha, sine of beta, that's minus 3/5. Sine of beta would be 1/2. So this becomes 4 square roots of 3 over 10 minus 3 over 10, which we can just write as 4 square roots of 3 minus 3 all over 10. All right, let's do one last problem here. First, let me introduce, we've talked about the sum and differences for cosine and sine. Let me quickly tell you what those are for tangent, and then we'll do another one of these problems where I don't give you the triangle setup, okay? All right, so for tangents, okay? Tangent of alpha plus beta is equal to tangent of alpha plus tangent of beta, divided by 1 minus tangent of alpha times tangent of beta. And then down here, tangent of alpha minus beta is equal to tangent of alpha minus tangent of beta, divided by 1 plus tangent of alpha, tangent of beta. Okay. So let's do the following. Let's find the exact values of this. Cosine of alpha plus beta, sine of alpha plus beta, tangent of alpha plus beta, under the following conditions. I know tangent of alpha, okay, is equal to minus 3/4, and alpha lies in quadrant 2. And cosine of beta is equal to 1 over 3, and beta lies in quadrant 1. All right, so let's just, I'm going to rewrite our right triangle trig here, because we're going to need this. All right, so SOHCAHTOA. All right, so sine of some angle is the opposite side over the hypotenuse. Cosine, right, that's the adjacent side over the hypotenuse. And then tangent of an angle is the opposite side over the adjacent side. All right, so alpha. So I'm going to sketch angle alpha for us. It lies in quadrant 2, okay? All right, so here's alpha. None of this isn't going to be drawn correctly to scale either, okay? So look, I'm going to draw the right triangle down here. So tangent is minus 3 over 4. So that's the opposite over the adjacent. Well, look, the opposite side of the angle must be positive because it's in quadrant 2, right? Just in the xy axis. And x has to be negative from the origin here. So this is going to be a 3, 4, 5 right triangle. So let's write what sine of alpha, cosine of alpha is, and tangent of alpha, just so we have them, okay? Sine is going to be opposite over hypotenuse, right? So for alpha here, okay? So sine of alpha, opposite would be 4/5. Cosine, adjacent over hypotenuse, so that would be minus 3/5. And we know tangent was minus 3/4. All right, beta is equal to, cosine of beta is equal to 1/3, and beta lies in quadrant 1. So here's beta. And look, cosine is adjacent, which would be 1 over 3. All right, so you're going to need to use the Pythagorean theorem here to solve this out, right? So I think I just want to make sure if I didn't make a mistake. Opposite. Yep, I made a little bit of a mistake here. I knew something was off. I just wanted to go back. Opposite over adjacent here. So sorry. So the opposite is 3 and minus 4. Sorry about that. Something felt off. My apologies. So sine here would be 3/5, minus 4/5, and minus 3/4. Sorry about that. Hopefully, don't judge me too harshly for that mistake. All right, anyways, going back here to this one. So you're going to need to use the Pythagorean theorem here to solve for this opposite side here. So that's 1 squared plus x squared is equal to 3 squared. So that's 1 plus x squared is equal to 9. So x squared is going to be equal to 8. And because it's quadrant 1, x is going to be equal to the square root of 8, which is 2 square roots of 4, or 2 square roots of 2. Sorry about that. And again, my apologies for that. It's a little bit of a typo there. So sine of beta, cosine of beta, tangent of beta. All right. Sine is opposite over hypotenuse, so that's 2 square roots of 2 over 3. Cosine we know is adjacent over hypotenuse, which is 1/3. And then tangent is opposite over adjacent, which is 2 square roots of 2 over 1. All right. Now we're going to go back, and now we're able to find these cosines of alpha plus beta, sine of alpha plus beta, tangent of alpha plus beta. All right, so here's what we know. Cosine of alpha plus beta is equal to cosine of alpha times cosine of beta minus sine of alpha, sine of beta. Which, just like going back and look at the formulas. Cosine of alpha is minus 4/5. Cosine of beta is 1/3. Minus sine of alpha, sine of beta. Sine of alpha is 3/5. Sine of beta is 2 square roots of 2 over 3. So look, they're both going to have a denominator of 15. So this is going to be minus 4 minus 6 square roots of 2 over 15. Sine of alpha plus beta, that's going to be equal to sine of alpha cosine of beta plus cosine of alpha sine of beta. All right, well, what is sine of alpha? 3/5. Cosine of beta, I mean, you could just look at it over here. It's 1/3. Plus cosine of alpha is minus 4/5. And sine of beta is 2 square roots of 2 over 3. So look, the denominator in both cases is going to be 15. This is 3. 3 times 1 is 3. Plus minus 8 square roots of 2. Because 4 times 2 gets me 8. All right, and now we're just going to do one of those tangents, okay? Tangents of alpha plus beta. So tangent of alpha plus beta is going to be equal to tangent of alpha. Just going back to the formula, right? So tangent of alpha plus tangent of beta divided by 1 minus tangent of alpha, tangent of beta. All right, so tangent of alpha, minus 3/4. Tangent of beta is going to be 2 square roots of 2 over 1. So this is minus 3/4 plus 2 square roots of 2 over 1. That's the numerator. Divided by 1 minus these. So minus 3/4 times 2 square roots of 2 over 1. All right, look, what you're going to have to do is, you notice how there's a 4 here? You want to put everything over a 4, okay? So this is minus 3 over 4 plus 8 square roots of 2 over 4 divided by 4 over 4. And here you can just multiply. So this becomes plus 6 over the square root of 2 over 4. This is why you do this, watch. So this is minus 3 plus 8 square roots of 2 over 4 divided by 4 plus 6 square roots of 2 over 4. And when you do keep, change, flip, really what's going on here is the denominators of the 4 are canceling out. And you're just left with minus 3 plus 8 square roots of 2 all over 4 plus 6 square roots of 2. And I'm going to leave it like that. And you could attempt to rationalize the denominator by multiplying it by the numerator and denominator by the conjugate. But here, just leave it like that for now. All right, class, I hope that helped. And again, my apologies for that one little mistake setting up this triangle. But, you know, you'll get a chance to practice this. And as always, if you have any questions, you know, please let me know.